Hello students, you are welcome back to Library Premium Educational Consult. In this video, we are looking at practical question on correlation and regression together. So if you are new on this channel, please consider to subscribe, like and share so that we can reach as many students as possible who may need this kind of tutorials to help them in their various field of studying and in relation to mathematics as well. So thank you once again for being part of this great family. So let's begin real quick for this video. So we're looking at the first question, question 1. So as you can see, the data below shows the monthly wages of Mr. Rockish and its respective units of production in Rollers Company Limited. So this is a table. You have the monthly wages for January, February, March, April and May. Then we have their respective units, 70, 90, 50, and 55, and 60. So the first question is, what type of correlation exists between the wages and units of Mr. Rockish in Rollers Company Limited? That is the first question. Then the second question is, that is B. What is the strength of the relationship between the two variables? That is variable wages and that of what? The production units. These are the variables we are talking about. Then C, depict the data above in the scatter plot. That is the C requirement. Then D, we are asked to calculate the standard deviation of the residuals in the data above. Then E, explain your answer in D above. So these are the requirements of the question, and even so that is what we are actually going to look at in this video, but we'll be using this question as a general question to tackle other areas to far as correlation and regression are concerned, so that we can cover all the aspects of correlation and regression in that case. So let's take note of that. So let's go into it real quick in this video. So the data has been given. We have the monthly data, that's the monthly wages and that's of what? The units that Mr. Rockish actually produced within the month, and in which respective wages are attached to it in that case. So let's see. So before you can do this, you must first of all ask yourself, you said the question A is, what type of correlation exists between the wages and units of Mr. Rockish in Rollers Company Limited? Before you can answer the A question, you must first of all even represent the data in a scatter plot. That is the option or the question C that the question actually told us to depict in a scatter plot, so that you can know the type of relation that actually exists. And even before you go on to answer that type of relation, ask yourself, is there any correlation between the wages and then the units that Mr. Rockish produced in Rollers Company? If that is so, then you can go on to determine the type of correlation that actually exists between the wages and the units of production produced by Mr. Rockish in Rollers Company Limited. So that is one thing we need to understand before you can actually move on. So the first thing that we will do is to have a sketch diagram for the data that we have, so that we can actually represent them in that case. So let's see how we can go about that. But before we come up with the diagram for the scatter diagram or scatter plot for the data, let's first of all have a table that will actually houses the figures, the wages and then the units in that case. So I'll first of all have my solution here. So I'll first of all have the values of my X. So let the units represent as X, then the wages represent as what? Y. Okay, so the unit will start from 70, then 90, 70, 90, we have 50, then we have 55, then we have 60. So that is that for X. Then your list for Y, which is the wages, you start from 50, 500, sorry, 500, then you come to 600, then you come to 100, then you come to 200, and you come to, lastly come to 300. So that will be for the X and Y. Okay, so after getting these values down, then you actually plot them in that case. You are going to plot it to know whether there exists a correlation or a linear relationship between the wages and then the units. Okay, so that's what you're going to see, or you're going to actually engage on. And even without even drawing, you can clearly see there is actually a correlation, and I'll tell you why there is a correlation before even you draw, right? So yes, I have a sketch for, so I have the sketch. So this is my sketch. So this is my sketchy diagram to represent whether there exists a correlation between the monthly wages and then the units of production by Mr. Rockish. So let's see. So first, I have for 70, and 70 move it towards 500, right? So my 50 will be here. Sorry, 70 rather. So 70 will be here. Then move it to 500. So I'll come and plot. I'll match up and see. So it's likely to be here, around where here, for 70, somewhere like this part. Then we have 90 match up with 600. So X 90 with 600. So what will 600 be? So that one also will be here. So 600 also will be here. So it is, we said 90, sorry. So 90 will be here, right? Sorry for that. Here 90 is here. So if 90 is here, then 600 will be around where here. 600 paper, so can have it here. But then if you use a graph to actually do this work. So if you are going by the graph, you go plot and then everything will be nice. But then I'm just doing a sketchy part to show whether there exists a correlation in that case. So let's take note of that. Then we also have 50, move this 100, so 50, it will be here, right? 50 and 100 will be here, somewhere here, yes. Then we have 55 and 200, so 55 will be in between this area, right? Then 200 somewhere here. So somewhere here. Then lastly, we have 60 and then 300. So that one also somewhere here. In this case, so this is how it will be. So after that, we can see that there is this pattern, right? That is actually, we can have a straight line being drawn here. So before Now you can see that there is this line, how this straight line being drawn. Right, so this is my line that I've drawn as my regression line. So this is my regression line that I've drawn. Just a sketch. So with this, what kind of relation can you talk about here? You can call this what? A positive correlation. A positive what? Correlation. There exists a positive correlation. This is a positive what? Correlation. So as you can see, as the number of units that you produce fall, you get less weight, which is 100. As you produce higher, let's say 90. So as you produce higher, which is let's say 90, get what? 600. And you see, so you can see this is a positive correlation. As production increase, more wages. As production decrease, less wages. So this is actually, there is a correlation in between these two variables, and in that it is what? A positive correlation. It is a positive correlation. So let's take note of that. So that is the first part of the question, which is what? A. So A part of the question has been answered. Then the next question, the B part. The question is actually asking us to find let's see the B part. The question is asking us to find what is the strength of the relationship between the two variables. So after knowing that there exists a correlation between two variables, there exists a linear relation between two variables, the next thing we need to do is to determine the strength of the relationship, whether it is a strong relationship or a weak relationship or a partial relationship. So that's what we need to take into account in that case. So let's take note of that. All right, good. So we are going to determine the strength of and in determining the strength of a relationship between two variables, we said we use a product correlation coefficient, product moment correlation coefficient, which is the R, the small r, if you remember. So I've given a link in the description section of this video. You can check the previous video. We have discussed intensively about these matters about correlation and regression. R square, R then itself, coefficient of determination, those stuff. We have dealt a lot about that, so you can check the previous video and then take it from there. You understand it far better. So let's progress and move on. So actually you have answered question A and then question C, because it said we should depict the data above in a scatter plot. So that's why we have actually depicted here. So you have answered actually A and C. So let's take note of that. A and C. So let's move on to calculating for the strength of the relationship. So in that case too, how do you also go by? So in that case, I'm always going to list my X and Y again, then I'll have a diagram. So I'll come up with a formula, and then based on the formula, we come out with a table to deduce and calculate for the R. So let's take note of that. So these are the values that we use to plot the scatter plot, right? So 75, 90, 650, 100, 55, 200, and 60, 300. So let's move on. So we are asked to calculate the strength of the relationship between the monthly wages that Mr. Rockish received and then the number of units that you produce. All right. So how do you go? We said that to calculate the strength, we use product moment correlation or coefficient, which says that here's the formula, which says R, small r, is equal to the summation of x minus x bar all squared. Sorry, that's the denominator side. X minus x bar multiplied by y minus y bar, and then divided by the square root of summation x minus x bar all squared multiplied by summation y minus y bar all squared. So this is actually how we determine the product moment correlation coefficient. So we are going to use this component to break it down, then we use it to solve for the r squared. Okay, so once I have x minus s by e, I'm going to have a column for x minus and a column for y minus y, and a column for x minus s bar all squared, then a column for y minus y bar all squared. And I also have a column for x minus s bar into bracket, y minus y bar all into bracket as one column. So this is what we're going to do. So first, I'll have what? A column for x minus x bar. Okay. Then I have y minus y bar. Then I have a column for x minus x bar squared. And I have another column for, another column for y minus y bar all squared. Then the last column I'll derive will be a column where I take the product of x minus x bar multiplied by y minus y bar. So that is what we're actually going to do in that case. So let's take note of that. So once we have these columns that we have to fill here, so here, this is what you do. You take a calculator. Then we are asked to solve for. So before you can start this or filling of this column, you must first of all find out your average. That's your mean, right, for x bar. So to find the mean of x bar, this is what you will do. You are going to add all the values of x. So I can say that x bar will be equal to 70 plus 90 plus 50 plus 55 plus what? 60, all divided by how many units do we have in the month? We have what? We have 1, 2, 3, 4, 5, 5. So we divide by 5, and the result will give you 65. Let's check whether that is true. So I have 65. Then you come and do same for y, in that case y bar. So the mean of y, so that one too, it is 500 plus 600 plus 100 plus 200 plus 300, all divided by what? 5. And then I'll have my y bar to be 340. That is what I have for my y bar. So you can also check and let's see whether it is 340. So 500 plus 600 plus 100 plus 200 plus what? 100 will give me that result. In that case, 300 will give me what? 340. So after getting these values, these two values, that is where you can actually do this. The column for x minus s bar, then y minus y bar. So let's take note of that. So after getting the values for x bar and y bar, you pick a calculator like this, right? So with this calculator, this is what you're going to do. You can key in this function. For the x, I can say that I have alpha, then x minus 65. So after I've pressed alpha, x, alpha, then x, right, minus 65, then I'll press what? Solve. So first of all, I'll solve for what? 70. So when I solve for 70, I had what? 5. So that's what you're going to do. Then you place the 5 here. If you can do your direct calculation. So this is a function you're going to actually use. Then you press the same, so you won't delete, you press what? 90. Get what? 25. Then the same thing. You press of 50 until you fill all the columns, which is what? Negative 15. Then so you have it here, like here. You press solve for 55 and get negative 10. Then solve for 60, then again negative what? 5. So that's how you also go. Then it comes to the y2, you use the same x, but then you have it in mind that you are dealing with what? Y. So the y was what? 340. So we're going to have 340 in there. So you go with the same approach, you press solve, then so forth, y, which is 500. Then you get what? 160. Then you do same, solve 600 and get what? 260. So actually that's what you're going to do in order to fill these two columns. So let's do that so that you can actually move on. Then solve for 100. I had negative what? 240. Then solve for 200. I had negative 140. Negative 140. So that's why we are doing right. Negative 140. Then I solve for 300. I get negative 40. Negative 40 in that case. So once you're able to fill out these columns, the next thing that you need to do is to find the square of the x minus s bar all squared, then y minus y bar all squared. So that one too, you have a function that you're going to deal with. Then the function will be what? Alpha x, then you squared it. Okay, you get this function. This function. So the same thing, you press solve, then you are dealing with the x part, and press 5, which is for 25. So you place it here, 25, you place it here, 25. Then you do same thing for 25 in the x minus s bar column. You press solve for 25, and you get what? 625. Then you do same for 15, you get 225. Then you do same for 10, you get what? 100. And you do same for 5, you get what? 25 in that case. So after dealing with the x minus s bar all squared, you also do the same thing with what? The y. You maintain the same function, but is that you are using the values for what? Y minus y bar, these values. Okay, so you solve for 160, and we're getting 25,600. Then you solve for 260, you get 67,600. You solve for negative 240, and you'll be getting positive 57,600. Then you solve for, so actually that's what you're going to do to fill out all the columns. So for negative 140, you're getting 19,600. Then we solve for the last part, which is what, 40, and you're getting what, positive 1,600 in that case. So after filling with that, then we come back to the final column, which is the x minus s bar multiplied by y minus what, y bar. These two are going to multiply, and this is the column that we are dealing with. Okay, so just take 5 multiplied by 25 multiplied by 260, negative 50 multiplied by negative 240, in that order. Then you fill it with this column. So let's take note of that. So I'm filling mine, so fill yours, and let's see whether you get the same values as we fill it here. So let's take note of that. So now these are the values that I have after multiplying 5 by 160, 25 by 260, negative 15, negative 240, negative 10 by negative 140, the same as we did here, negative 5, negative 40. So I had these values being filled here. So the next thing that you can see in the formula, we have what, summation x minus s bar multiplied by y minus what, y bar. So that is here. So I'm going to sum these values, all right? Then we come to the square root of summation x minus s bar all squared. This one will sum them up. Then also do the same thing here, all right? That's what we're going to do. So we're going to sum them up. So we're going to sum these values up. So when I did that, I had here to be 1,000. So try and let's see whether we get the same thing. Then here too, I had here to be 172,000. Then here I had here to be 12,500 as the total sum, right? So now once we are able to satisfy this, therefore we can conclude by substituting these values in the formula. So we can say that summation x minus s bar y minus y bar is what, 12,500, right? Divided by the square root of, I have x minus s bar all squared to what, 1,000 multiplied by 172,000 as the next y minus y bar all squared. So in that you're going to get, so taking my calculator and I punch, I had 0.9531. Though we have as non-terminated values, so but I just terminated to just 4 decimal places. We are going to get something like 0.0 0.953, then other values are behind this, but just terminated to just 4 decimal place in that case. So this will be our value. So what does this out tell us? It tells us that this is what, a very strong what, positive what correlation. It's a very strong positive what correlation that exists between the wages of Mr. Regression and the number of production he's able to produce in Rollers Company what, Limited. All right, so that is that, a very strong, so a very strong what, positive correlation. I think that's what we did here when we used the graph. This graph, when this graph, this is what we had. You see, positive, but this one is a very strong one. So you see all the values, though my lines wasn't not that straight, but you can see that it lies perfect if we were to use what, a perfect word graph to actually present. So that's actually what the relation between the wages and salary actually tell us. So a very strong positive what, correlation. So that is that. in that case. So you are able to know the type, you're able to know the strength, you're able to depict it on the scatter plot. So, but then you can also be asked to, let's say, find the correlation, determination of correlation, coefficient of determination, coefficient of determination. And how do you also go by that? If you are asked to find, the question, we weren't asked to calculate that, but then you can be asked to calculate that. How can you do that? We said coefficient of determination, which is what? R squared, right? Coefficient of determination is what? R squared. That's why we said coefficient of what? Determination. That's why we said it's what? R squared. So once you're able to find the R, you just squared it. Okay, so here, all I will do here is just to take 0.953 and I'll square it. When I squared it, let's see, 0.9531 squared, I had 0.9083991. All right, so remember we said here you multiply by 100 so that you know the percentage of variations in which one variable have or influence, actually influence what? The other. Okay, so when I multiply this by 100, I'll be getting what? 90.8, let's say 2 decimal place 8 what? 4%. So you can still see that because of the very strong relationship between the two variables, just a single what? Value or percentage out of the total 100%, 90, let's approximately 91% variation exists between what? The number of genes that we're able to produce and the wages you're able to receive for a particular what? Production activity. So this actually tells us the variations that the two variables present to each other in their relationship. And this shows a clear cut of a very strong relation between the two from our R determination of what? Coefficient of what? Polar moment of correlation coefficient. So this is actually our what? Coefficient of determination. If you're asked to do that, you should be able to do in that case. So that is that one in that case. So our last thing that we are left with is to actually calculate this question. Calculate the standard deviation of residuals in data above and explain the answer. So, but before you can actually calculate the standard deviation of residual, you must first of all know your regression equation. And how do you determine what? Regression equation. We said regression equation is always of the form. Regression equation is always of the form y is equal to a plus what? Bx, where y is the dependent variable, x is the independent variable, b is the slope, and a is the intercept of what? Y. Remember that? Sure. So before you can actually solve the standard deviation, that's what you need to do. So let's find what? The regression what? Equation. Let's find this. So how do you determine what? A. We said to find A, that is the intercept, the small a, it is actually your y bar minus what? Your b, the slope, multiplied by what? X. This is how we determine the value of what? The intercept, which is for the a. But then you can't determine the a where you don't know what? The slope, which is what? The b. So how do you also determine the slope? The slope is equal to, as I said in a previous video, we said it is the numerator of what? The correlation coefficient x bar multiplied by y minus y bar, all divided by just the sigma of what? X minus x bar all squared. And we have been able to know the value for x minus x bar all squared in the diagram that we produced. We also know the value for the summation of x minus x bar and d. So all that we need to do is do what? Substitution, and we are good to go. These are the values I'm talking about. So these are the values I was talking about. You see, we know we have this, which is 1000 x minus x bar squared. Then we have what? X minus x bar, then multiplied by y minus y bar squared. We also have this. So should I just pick this value and divide it by what? This, and that will give me my sloping, or the slope. So that is actually what we need to do in that case. So let's see what the result will be. So now, if I want to substitute, I can say that here was giving me 12,500, and I divide by what? The overall is what? X minus x bar all squared is 1000. So when I divide, I had my answer to be 12.5, and this will be my slope, or the gradient, as you know way back at XHS, that's senior high, right? Yeah. So this will be my gradient or the slope. So once I'm able to know my slope, then I can go on to determine my what? Intercept, which is what? This. So I can say that let's have that one here. A, small a is equal to small a is equal to, I know my y bar is what? 340, this, right? Minus, I know my slope is what? 12.5. And I know my x bar, sorry, here is not that. X bar is 65. So therefore I can have the total and compute it. So let's do the calculation and see. So when you do the calculation, you can clearly see that you'll be getting the total of what? Negative 472.5 as my A. So therefore I can conclude that my regression line is equal to negative 472.5 plus my slope, which is 12.5, multiplied by my what? X. Or somebody may also prefer to write in this way, or my slope, which will be equal to 12.5x minus 472.5. Anyway, still get your answer right in that case. So let's take, so that's how we determine what? The regression equation in that case. So that is regression. So after finding the regression equation, that's where you use the values for you to determine the residual. So let's go how to determine the residual. So that is my regression of the equation that we have actually determined. So before you can go on to find the standard deviation of the residuals in the data above, you must first of all determine the residual. We said to calculate the standard deviation for a set of data, or for a residual, a set of data, yes, we said it is the root mean square error, right? Root mean square error, which is equal to the square root of the summation of y minus what? The dependent variable, the regression value divided by what? N, but then we're going to square it, and divide by the number of what? Errors, isn't it? So we said before you can actually solve for this, you must first of all find the error. So but then before you can determine the error, you should be able to determine that's the residual you're here to determine, but you should be able to determine the predicted what values. And how do you determine the predicted what values? We use the observed values of what? Y, which is this, the Y that we're given in the question there, 500, 600, 100, 200, and 300. That's what we're going to use to actually determine the predicted value. After that, we compare that predicted value with the same what? Values of Y. Then we know whether there was an error before you can compute for our standard deviation. Here is the root mean square error. So let's take note. So this is what we're going to do. We have my Y value should be here, 500, 600, 100. That will be the Y value, sorry. Then 300. You're actually going to use the values of X to make the prediction, sorry. I said Y. The Y you're going to subtract after the prediction. Then we have 55. Then we have 60 in that case. So we're going to use the values of X because you can see the X here to make the predictions after you compare it with the Y here, the one that we observed, to see whether there was what? Actually a variation, which is what a deviation in that case. So let's see. So you just take the equation. So if when X is equal to say 70, what will be the value of what? Y prime, right? You're going to what? Negative 472.5 plus 12.5 multiplied by what? 70. This is what you're going to do before you can get your predicted values for Y, which is a dependent variable, right? So when I solve, I had a total of 402.5, and here too you can use your function that I've taught you. You can have this function the calculator, then you continue to press solve. Let's say it's 90, and you get your answer like this. Press solve 50, and you get your answer in that form. I hope that is clear so that you can easily move on in a very sharp way. So first we had 402.5, then the 90 I had 652.5, then the 50 I had 152.5, then so for 55 I had 215, then when I saw for 60 I had I wanted to be 277.5 in that case. So this will be my predicted what value based on the regression what equation that we just did one sample here. So the rest I just use the calculator with the function, this function, to solve this function. So all that you need, once you get the function on it, then you just press solve and solve any value you want to solve. Let's say 80, then you continue. So I press solve, then you are good to go. So that is the function actually I used. So let's take note of that. So after getting the predicted value and you have the observed, therefore we can say that to find the residual, we said we use small e. It is equal to the observed value, which is the Y, original Y, minus the predicted value, which is the what? The Y HR, or the normal one we are using here in that case. So let's deal with them one by one. So we're going to have also, because I've written here, I'm going to have it here, don't worry. I have we're going to have y minus y prime, also a column for this to fill, right? So all that you need to do here is a calculator, so that we are good to go. You compare the observed value and then the predicted value. What is actually happening here? 500, 402.5. This what? 97.5. Then you do same for the rest. So you just comparing, right? So where there is negative, you just write negative. Where is positive, you just write. So that's why you're actually comparing. So I'm filling mine, you also fill yours, and let's see the outcome, whether the effect will be the same or not. So let's see. So these were my outcomes: 97.5, negative 52.5, then negative 52.5, then I also have negative 15.0, then positive 22.5 when I compared the two. That is what I actually have, all right? Or when I subtracted, that is actually the case. So after getting this, then you find the square. You're going to have a square. So I should have actually produced a better table. So let's have it here. So you're going to have what? So don't worry with my presentation, okay? I should have actually arranged so that you could have appreciated it as we did for the first one. But that's yes to the same print we actually apply. So sorry for the presentation in that case. So here, going to find what? So you said after finding your error, you find the square of the errors, right? So y minus so observed value minus predicted value, and I square. So all that you're going to do here is the same. Remember your function. In what? S and squared it. So the value is that square. So any values in there, first is what? 97, also for 97. So you're using that to fill the space in that case. So do that. I'm doing mine. So these are my outcomes that I have when I find what? The error square, right? These are my outcomes. So the next thing after finding the error, after finding the error that we said is the observer and the predictor that I use the regression equation to solve. Then you find what's the square of the error. Then after finding the square of the error, you come and find the mean of what? The error. So we are going to find the mean of these values, right? So you add all, then we divide by number, which is, so the number is what? 5 in this case. So let's add all, and then we divide by what? 5. All right. So let's do the addition in that case. So when I sum them up, I had a total of 15,750. I hope you had the same thing, right? After getting this, now you are able to find the mean, right? You are able to satisfy what? The mean, which is the m. Then you find what? The square roots. So this is the mean. Hey, sorry, I said the mean. Sorry. I said after finding the total, that is what I had. So you are going to what? Find what? The mean. Actually, you're going to find the mean. So in finding the mean, it's actually going to be, so let's bring it here. It's actually going to be, if you're finding the mean, it's actually going to be, it's actually going to be summation of y minus y bar all squared, then divide by what? N. So that will be the mean, and then you're going to be what? 15,750 divided by what? How many? 1, 2, 3, 4, 5. So you divide by what? 5. Then your outcome, 9 divided by 5, I had 3,150. 3,150 in that case. 3,150. So after finding the mean, then you find the root of the mean. So after finding the mean, then you come back and find the roots, square roots of what? Of the mean here, this mean. Actually, this mean. Okay. So therefore, we can say that. The standard deviation is the mean square error is equal to square root of 3,150. So take the square root of 3,150. So I had the mean to be 56.5 sorry, the square root will be 56.124124 56.124848608. So let's say two decimal place becomes 56.12 in that case. So this will be my standard deviation. What does this standard deviation tell us? What does this standard deviation tell us? You can clearly see that what we had in the diagram when we did the scatter plot, this is what we had, right? If you remember, this is what we had. You can clearly see that the variables were lying very close on the line, isn't it? Exactly. That's what actually. So we can say that though this a bigger number, but yes, still based on the values that we used as a wage, and then so we can determine that actually the standard deviation was small, at least a little bit was small. So the values were all lying down. It was lying exactly or closely on the regression line. So we'll be able to make that inference. Because we said in a previous video that for you to make a better reflection of the values of the variables, then we are saying that a smaller standard deviation will actually have a good picture of how the values of the variables actually represent the regression line. And that's what we said. And you can clearly see that here the values actually lies on the regression line. So it's actually have a good picture when you use the standard deviation as a means of explaining. So that's the explanation behind this. So this is a good standard deviation, residual standard deviation error, and actually it has reflected the values on the regression line. So actually this is where we bring an end to our presentation on the data of Mr. Rakesh in respect to its wages and the unit that you produce in Rollers Company Limited. So thank you once again for watching this video. If the video was helpful to you, please consider to subscribe, like, and share so that we can reach as many students. So I will see you in the next video where we discuss other matters in relation to stock. So before we meet, I say goodbye. Bye bye. Thank you.